This week on LCARA Ham Radio, have you ever needed a dummy load for testing your HTs or maybe a length of cable? Well, we're going to take some parts maybe you've never seen used before, and we're going to create a dummy load. That's what's coming up this week on LCARA Ham Radio.
Come visit. She's coming Sunday over here, and we're going to go to.
We have to solder a wire through there, though,
second
to solder to this.
Right.
Then solder the tail out there.
Right.
Around the back.
And then pick up one of the heat sinks over there.
Al? Alright, you ready to plug it in? Yeah. Yeah, I saw that.
And that'll have to be mounted to that. And then
So,
install it like that. The heat shrink it.
Alrighty, so Steve's given us a nice introduction. We're going to be taking these pieces and we're going to be creating a dummy load out of them. And what he's utilizing here is a little bit of Romex wire probably or something similar to act as kind of that center conductor, but we're going to be soldering one of the leads of the film resistor. Now this film resistor is 15 watts. Don AC4DM has some 100-watt versions, and we're going to be building another one for more powerful radios, but this one's for HTs and for cables. And you can see he's showing how we're going to drill and tap the film resistor, or actually we just drill the film resistor, but we have to put a hole in the heatsink and then tap it so that that screw will keep it nice and snug against it. So Don is showing us making the hole a little bit larger on the film resistor. Now we had a really good showing this evening. There's KD6 FTR, and we also have Fred over there, and he just got his call sign, so I don't have one to give you yet, but in a future video we'll certainly share that. And again, Don's showing utilizing that drill to create the holes that he needs. So he used a smaller bit just to kind of make the hole a little bit bigger, and he's going with a slightly larger bit that he'll ultimately then insert the screw that we're going to use, which will then attach it to the heatsink. So we're just using an assembly line approach here. He's going ahead and making several of these film resistors with the right sized hole. Now, KK4YUG is lining up his heatsink with this film resistor, just trying to get an idea of how we're going to mount that. Where do we want to put our hole on that little bit of heatsink? Do we want to orient the heatsink that way or the other way? So we're going to put it into the vise at this point to make it a little bit easier to drill, but when I say a little bit easier, that's a little bit relative. And so we tried different ways of trying to put this in the vise, but ultimately what it came down to is we got to close that vise pretty tight and then just don't press very hard on the heatsink. And then he put a little square or bullseye on that heatsink so he knew where he wanted to drill. We could probably have used some type of tap as well as a way to give us an indentation. Now we're using a drill bit that's going to be the size that we need, a little bit smaller than the tap that we're going to use, because the tap is also going to take a little bit of metal out, not a lot, but a little bit, but put the actual grooves that we need for the screw. Now, a lot of these tools come from AC4DM's inventory, but KK4YUG has been an electrician for a very long time, used to work on motors, windings and things for water pumps and whatnot. So he's got a lot of these tools as well. So at this point, we've enlarged the hole on the film resistor and we've created a hole on our heatsink. So now it's at this point, we're going to take our film resistor, we're going to put the screw through that 15-watt resistor, and then we're also going to then screw the little screw there into the heatsink that we've now drilled and tapped. AC4DM has all the charts and so forth to say, well, what size drill bit do you want to use when using this size screw? And so this makes it easy. And of course, he's done this so many times for all kinds of projects. It's amazing that he knows exactly what the next step's going to be. And then Steve just kind of chamfered the hole a little bit so that we don't have any burrs or excess material on the outside. Now, anytime you're putting some type of semiconductor against a heatsink, it's really good to use a little bit of heatsink compound. So that's what Steve is putting on the resistor. This will give us a good bond with the aluminum there on the heatsink, and the heat will transfer more effectively. And then we're back to putting our screw back in. You'll also notice there's a little star washer underneath it that's going to bite in to the resistor so that the screw itself won't back out. One of the reasons to use such a star washer is these dummy loads are going to heat up and contract, and potentially that screw could back itself out or become loose. Although actually when we put the heatsink on it, that's going to be a little bit difficult, but not a bad idea to go ahead and use that. So you can begin to see how this dummy load is going to look, at least from the dummy load part of it, but at some point we need to attach this to our SO259 connector. Doesn't that look nice? So not a lot of effort here just to put this together thus far. So now we're going to turn our attention to the SO259 portion of the dummy load. So we have some electrical wire here. This is solid copper, and we need a little bit of it to put in as the center conductor on our SO259. So Steve's putting together the tools that he needs, and he's getting an idea of the length that he's going to need. And in this first go-around, we could have used some of those octopus hands that you have with a lot of soldering stations, but at the time of this hands-on we were doing, we didn't have any, so we're just kind of making do. So some of you are going to cringe, but that's okay. It's cringe-worthy. But we want to solder one of the legs. It doesn't matter which leg. It's not a diode, for instance. So we want to solder one of the legs of this film resistor to this copper wire that we're going to use as the center conductor. So Steve has basically tinned that length of wire. Now Don's coming along with a really nice soldering iron, a Weller. Some of the soldering irons that are out there can certainly do a wonderful job, but for this type of work where we're just tinning the wire, the Weller gets nice and hot and is a little bit, it spreads the heat out a little bit better. Now Steve's going to come along with a little bit more fine soldering iron, and what he's going to now do is add solder and heat up the solder that was tinned on the wire, and hopefully we can get this leg attached. You can see some of the flux has already dripped onto the table. He had already put some of that on there as well. And the reason I'm leaving all of this in, I could have edited a lot of this out, but everybody who builds something, you've been through these kinds of situations where you don't have exactly maybe what you would want to use. So it becomes a little bit of a challenge, not just putting together a dummy load, but literally a challenge. So now Steve's going to put a little bit of solder on that leg so that he can put it over on the wire, heat it up, and it should just basically attach itself. Now we're going to add a little bit more solder. Here comes Don again with his Weller. Steve's finding out that that soldering iron is just making it a little bit difficult given that we don't have those arms. But nonetheless, we need to heat up a little bit of solder, make sure it transfers to the leg, let it cool, and now we have that leg attached to our wire. It doesn't take a lot, but it's just a little bit fiddly given that we didn't have those arms. So in comes a shot of a dummy load that's already been created and just heating up some of that heat shrink. But you can see the wire that we just connected to the resistor. We put a little bit of heat sink on it as well to cover up the wire going into the resistor. So now Steve is inserting the copper wire. He cut it to length to go into the center conductor of the SO259. And the one thing you want to make sure of is that other leg that isn't attached yet. We want to get it far enough up on the shielding of the connector to make sure that we can then solder that to the connector. So as we look around the room, we have a few other members putting together their dummy load, and you can see they've got the right equipment. We've got KD6FTR here. He's got his arms out there where he can place things and hold it. I tell you what, when you're soldering, you need like 4 hands, and those arms with the clips on the end really make a difference. And this is a better shot of that heat sink that is covering up a portion of the wire up to the resistor. AC4DM couldn't help himself, so he got out the MFJ analyzer and he wanted to check the first dummy load that was created this evening. I believe it was actually Steve's. You can see it's a 1-0 SWR, which is what you would expect. And look at that resistance, 49, and a little bit of the impedance there, reactance, I should say, of 2, but really, really close for how that resistor was manufactured. I believe these film resistors, you can actually get them where the tolerance is about 1%. So if you're used to working with the old carbon-based resistors like Dawn has, where you're looking at a gold band is this much tolerance and so forth, these film resistors are very, very exacting, and you can get more, or you can get different ones that are even more precise. Here we're looking at the analyzer once again. We're just going through some of the different bands to see if it makes a difference with the dummy load on it. The SWR there in the top right corner is 1.0, can't be any better than that. And you can see that that resistance, 49, isn't changing as we go through some of the other bands. So that's a good test. There's our member with his arms, and he's a smart man that he's got this equipment. He brought it because he knew for hands-on we would probably be making a kit, in this case the dummy load. And you can see how much easier, or at least a little bit easier it is now that that wire is in a position where he can start tinning it more easily. All right, so now we're back to the capable hands of KK4YUG. And you can see he's got a length of that solid copper wire that we're going to use for the center conductor that we're ultimately going to affix to the film resistor. Now, he's already put one of these together for himself, so this was actually helping me a little bit because I'm running the camera. So we're back to putting a little bit of tinning on the wire here. It's using those clines, the pliers below it, to kind of hold it steady. So you can see he's adding a little bit of solder here to his iron and to one of the legs of the resistor. Now, this is the one that I put together. The first one we saw was his, and he's helping me out. So a little bit of solder on that leg, and then we're going to move this over to the wire. Now, when you start soldering this stuff, all the components can get quite hot because of the soldering iron. So he's holding it with his pliers, not only to protect his fingers from the heat, but to also hopefully give him a little bit more stable soldering station. But as you can see, we're still kind of fumbling a little bit here. So we do eventually get it soldered to the wire. We put on a length of heat shrink where the wire is and where the leg is now soldered to it. And we're going to take our heat gun, and we're going to make sure that that heat shrink conforms to the wire and the leg nice and tightly. This is to make sure that it doesn't come apart. It gives it a little bit more strength in case the dummy load gets bent or something, but it's basically to give it a little bit more support. Now we're inserting the bit of wire connected to the heatsink resistor component into the center conductor barrel on the SO259. So that's Steve seeing how much he's going to need. And the cameraman here is not doing a great job, but eventually I'm going to move it. There we go. And you can see he's got it inserted. And we need to make sure that second leg on the film resistor is on the outside of that grounding jacket. And because the heatsink is on there, it's a little bit difficult to get into that center conductor, so he's ensuring that he can do that. And again, we want to get it up as close to the edge of the outside barrel as we can. So here come the clines. We're going to cut off the part of the wire that we don't need, and then we'll clean that up a little bit more in a moment. So the next step in the process is we need to tin the wire that's going to be inserted into that center conductor area of the SO259. So Steve is making sure that he's got a little bit of flux on there, and then eventually I think we end up putting this in the vise to tin it properly, but I think he's still thinking about it. He's still looking at doing this with his pliers, but I think we ended up going to the vise coming up here in just a moment. So here we have it actually in the vise, and this will should make tinning that wire a little bit better, or a little bit quicker and easier. Now he's gone back to using the Weller soldering iron here because it does a really good job. It heats up more quickly, gets a little bit hotter as well. And he's going to start adding some solder to the wire. And again, we just want to get this tin nicely. When we insert this into the SO259 connector, we're going to have a lot of conductive material that's going to fill that inside section. We're going to add more solder once we get it inserted from the tip. So Steve begins the process of inserting what we've created and added some solder to into that center conductor. You want to make sure that you've got a little bit of solder there, so make sure we have a good connection. But sometimes also you have a little bit of a bulge and it doesn't go in very well, so you might have to file that down just a little bit. So he's going back after filing a little bit, or maybe we used a pocket knife, I don't remember for sure, but he's trying to screw it on a little bit so that we can get it in there. You can see the second leg of the resistor is still hanging out there. So we made a couple of more adjustments, and it seemed to go into the connector much more easily this time. And he's bending that second leg to where it's much more closer to that grounding shield. Eventually we're going to solder that as well. So far things are coming together, but you still need to fiddle with this or that little component sometimes. Make sure that all of it's going to come together. So you can see all the components now before we do the final solder on that other leg. So Steve's going to go ahead and add solder. We've got some flux there. We're going to add some solder to make sure we get a really good connection between the solid copper wire coming up through the center and the actual connector itself, the center connector. So he's heating up the center connector there and then trying to add some solder. Once again, we probably should have put that connector a little bit more tightly in the vise, but eventually we did get everything in there. There we go. Now we're going to move to soldering that last or second leg onto that outer jacket that's used for grounding if you had a cable on the end of this connector. And Steve's going to add a little bit of heat, and then he's going to hopefully melt that solder to where the leg and that jacket are now one. Making it hard on the cameraman. So we got a blob of solder there. I think he's going to clean that up a little bit. And the good thing about this little project, it doesn't have to be pretty. I know some of you again are cringing, but it doesn't have to be overly pretty. We're just trying to create a dummy load. It's not terribly sophisticated. We've done a little bit more snipping here, but we also need to file that down just a little bit more. So Steve's going to make that end tip a little bit better to go into a cable, or in this case, maybe the analyzer. Alrighty, a little more solder was deemed necessary after we had done a little bit of filing there. Want to fill that gap up nice to where we get a really nice kind of roundish edge. I think we still used a pocket knife to square that up or round that up a little bit so it would look a little bit nicer and insert more easily. Now we're taking our blue heat shrink. Now we're using blue here because we like the color blue for LCARA. It's one of our colors. And so this is an LCARA blue heat shrink that we're going to put over the resistor and where it connects to the SO259. And everything's going to be nice and wrapped up to give it that rigidity and make it a little bit more stable, more usable. And even if you had it in your hand or bumped it or anything, it's not going to bend nearly as easily because we've got this nice heat shrink on there. I believe this heat shrink was a 3-to-1. Again, be careful when using a heat gun, of course, and Steve touched the heat shrink just to turn it a little bit, but by and large, you don't want to touch anything that heat gun's been blowing against. Steve's taking a little bit of a chance there, but he's just touching the end, which isn't all that hot. And now you can see that heat shrink is all the way around, and essentially that is done. We could clean up that tip a little bit more, but ultimately, as you'll see, it inserts just fine. So we're taking our multimeter, and we're going to see whether or not we've accidentally grounded the end. We're touching one tip to the of the multimeter to the tip on the connector and the other end of the multimeter to the shielding, and you can see 49.8. That's very nearly 50 ohms. And now we've got it connected to the analyzer. You can see we've got 50 ohms on the analyzer, so maybe it's rounding up just a little bit, with a reactance of 1, so this one's nearly perfect. Again, as we go through some of the other frequencies, the display does not change hardly at all. So the dummy load is definitely made for a purpose and should work wonderfully. Now at this point, we could have connected a cable to it and tested a cable. Sometimes you'll have a cable and you wonder if it's still a good cable. Does it have a short? Is it showing resistance higher than it should be, for instance, with a dummy load on the end? And this is a great way to test that. Or you might want to test an antenna or an HT connected to a piece of cable or something, just to double check. And here we're looking at the finished product. You can see we worked on that end just a little bit, still a little bit pointy on one end, but take my word for it, it worked just fine. Alrighty, so to wrap up the video, this is one of our LCARA hands-on events. We like to have these hands-on events to build kits, in this case to build a dummy load. We've created cables, we've done Anderson power poles. If your club isn't sponsoring one of these nights where you build things, maybe it's something you should add to the calendar. This is a great way to get some of your new members involved as well, because they may not know how to build a cable, create a dummy load, install and attach Anderson power poles. All of this can be taught. You'll have people in your club that can act as mentors and show your new folks some of the skills needed in the hobby. And then we have our final shot here of the 5 dummy loads that were created that night, including the one that Chris and AC4DM created for our analyzer giveaway just a few weeks ago. For the Lake Cumberland Amateur Radio Association, I'm KY4 BDP Brian. We hope you enjoyed the video and gave you some inspiration. 73.